Okay, good. So we remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. I'll take any information, no matter how small. What do we know?
It helps you find the hypotenuse of the right triangle.
Good. It'll actually help you find any side of it, but the hypotenuse is like you can find any side of it as long as you have enough information. But what specifically up there is the hypotenuse? Like which one of those is the hypotenuse? The C is always the hypotenuse. So just make yourself a note because that's one of the biggest areas. It's like where you put A and where you put B does not matter, but C is definitely the hypotenuse every single time. When can I use this? Like where do I apply this? Like what situation would I be like, oh, I could use the Pythagorean theorem for that? Colette. Trying to find what? Okay, so let's say that I have this triangle right here. And I have 2 and 6, then I could find the other side of that triangle? I disagree with you. But there's only one little caveat about why I disagree. Carson?
I can't see it on Canvas.
Okay, so log out of Canvas and relog into Canvas.
I already did that twice.
All right.
I can't see the course.
Yes, ma'am. Has to be a right triangle. That is the most important part. So we couldn't do it there, but we could do it in a situation where I know it's a right triangle. So it has to be a right triangle. And if so, then I could use it to find a missing side. If I've got 2 sides of that triangle, I could find the third. And we're going to apply that, and we're going to learn a little bit more about it. That was just kind of like the basics of the Pythagorean theorem. We're going to add on to it and make it a little more in depth. Okay. So, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. All they're saying this is if you take the legs and you square them and then add that together, the sum of those two things, and then that'll be equal to the hypotenuse squared. That's all it's saying right there. So the square, when they say the square, that means that that side is being squared of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Take the legs and square them, add it together, that will be equal to the hypotenuse squared. Okay, so we have these things called Pythagorean triples. This is really important because we're going to be talking about Pythagorean triples, and these are some very common ones. First of all a Pythagorean triple are 3 numbers. First of all, it is 3 numbers that represent the sides of a right triangle. So these are the sides of a right triangle. Now, to be a Pythagorean triple, like if I give you 3 numbers and ask you whether they are a Pythagorean triple, here are some things that have to be true for them to be a Pythagorean triple. First of all, none of the numbers can be 0. But that should be obvious because we can't have 0 for the side of a triangle. We already know that the lengths of things cannot be 0 or else they don't exist. You know what I mean? We can't have a 0 length unless it's not there. But the side of a triangle will have some length. It cannot be 0. It has to have a length of something. So it needs to have some sort of length. And then additionally, all of these numbers have to be whole numbers. So we're not looking at like 1/2. We're not looking at, 0.75. We're looking at whole numbers here. If you notice, all of these are whole numbers. And in just a minute, I'm going to show you why these are very useful to you. Like why you are going to really like, if you know these, why you are going to really like these. And then finally, and I'll explain this in just a minute, these numbers must satisfy a squared plus b squared equals c squared. And I'm going to elaborate on what that means here in just a second. I'm drawing out 4 right triangles here to talk about what I mean when they satisfy a right triangle. So first of all, these all are whole numbers. None of them are 0. The question is, do they satisfy a squared plus b squared equals c squared? What I mean by that is, do these numbers work as the sides of a right triangle? And to test it, like notice this first set is 3, 4, 5. I'm going to go ahead and test this. 3, 4, 5. How did I know that the 5 went on the hypotenuse? How did I know that it didn't go somewhere else? It's the longest side. So the longest side always has to be the hypotenuse. Like I can tell you that. Like here's the hypotenuse, here's the hypotenuse, here's the hypotenuse, here's the hypotenuse. Why? Because they're the largest numbers. And now here I've got 6, 8, 10. Here I've got 5, 12, 13. And here I've got 7, 24, 25. Now, how do I know that these numbers actually work? Like, how do I actually know that? Well, I actually have to test them to say, are these numbers a Pythagorean triple? So here's what I'm going to do. I'm going to do 3 squared plus 4 squared is equal to 5 squared. And I need to check to see whether this is a true statement. If this is a true statement, great, then it can be a Pythagorean triple. So 3 squared is, and 4 squared is, and 5 squared is. When I add 9 and 16, I get. Notice that this has made a true statement. 25 is equal to 25. This is definitely a Pythagorean triple. I have checked it. Now, here's why you're going to like this. When I was doing the SAT prep for some of the kids, we were looking at some of the right triangles, and it had triangles like this. There was a right triangle, and it had sides of 3 and 4, and they had to figure out the missing side. And they were all like, oh, yeah, let's just do Pythagorean theorem. And I was like, why? I was like, why would you do Pythagorean theorem? This is one of the most common Pythagorean triples in the world, meaning like it'll always make a triangle, a right triangle, 3, 4, 5. So this is the easiest one, in my opinion, to remember, is that if you see that one of the sides is 3 and one of the sides is 4, then the last side will always, of a right triangle, be 5. If it's a right triangle, it will always be 5. That's a guarantee. That is always going to happen. It is a Pythagorean triple. What also works is it also works like this. Here's the exact same numbers. So notice it's a right triangle, and I have 2 of the numbers. I've got 3 and 5. If you can identify, you're like, oh, that's 2 of the numbers in a Pythagorean triple, I know that this last one has to be 4. I can do it with no math at all. And if somebody said, well, explain your work, I could just say, that's a Pythagorean triple. There's your work for it. That's a Pythagorean triple. Like, I already know it. Now, the good news is, and I don't have to test all these, I could, but all of these are Pythagorean triples as well. And they're the most common ones. So here's what I'm going to tell you. And you can do this or you can not do this. Those of you who choose to do this will find that you're able to do your math much faster and much easier and save yourself a lot of work. These are so common. They come up all the time. These 4 sets here happen so often in right triangles. In math classes, on SATs, all sorts of things, they happen all the time. If you can remember these, like this series of numbers, that 3, 4, 5 is a Pythagorean triple, 6, 8, 10 is a Pythagorean triple. I'll tell you why you should be able to remember the second one. If you can remember the first one, 3, 4, 5, how is that connected to the second one? Yeah, it's just the second one is that just doubled. Now, the third and the fourth, they're their own unique things as well, but those are 4 that you can always do, that if I see something and I'm like, oh, give me the third side of this triangle, and you see 25 and you see 24, and you know it's a right triangle, it has to be a right triangle. That's got to be part of the deal. For a right triangle, you go, oh, wait, this is a Pythagorean triple. I know these numbers. I just know that's 7 right there. It'll always happen. Now, you could sit there, and if you're like, I don't remember my Pythagorean triples, then just do the Pythagorean theorem each time, and you can figure it out. But it takes way more work than just saying, these happen all the time. Like, they come up all the time. And the sooner you can commit these to memory, they're not going to just go away after geometry. When you get to Algebra 2, you're going to use them in the unit circle, and you're going to start doing stuff with them. And then when you go to take your SATs, these are so big. They love right triangles on SATs. They come up so often. So I'm stressing this for a reason. It's a huge thing right here. Any questions on those? Because that's probably it. That's all we're going to talk about for Pythagorean triples. Okay. So now we are going to actually do some of these. So let's talk about A. Walk me through it. First of all, it is a right triangle. This has to be a right triangle for us to do what somebody's about to tell me to do. Yes, sir.
So what's on the corner, so it'll be 5 squared plus 10 squared. And do you make a c squared, you just put y squared?
Yeah, you can write y squared. Yeah, so because this is what's there, we take the y and square it, so it's perfect.
So then you find the square number, so 5 will be 25, and then 10 will be 100. So 25 plus 100 equals y squared. And wait. Yeah, y squared equals y. Are you solving?
Yeah, we're going to figure out what y is.
So 125 y squared equals 125, and then the square root of 125 is
5 times 5 won't give me 125.
125.
What?
25.
Is it? I don't know. You think so? Or you know so? You did the math? That's what I'm saying. We're not just throwing out guesses here. If this were a test, would you be okay with that? Here's the thing. How many quarters would it take to make $1.25? Let's take a moment. Like this, I'm not going to... It would take 5, right? So 5 times 25 would give me 125. So 25 times 25 is probably bigger than that. But here's what I want to do with this. Okay, let's say we're stuck. We're like, I don't know how to break down 125. I don't know the square root of that. But just a moment ago, we said that it is 5 times 25, right? It's 5 quarters, yeah? Okay, so y is equal to the square root of 5 times the square root of 25. I have some people who are in other apps right now. I would recommend closing those. What am I going to do with this? Why is this line right here better than where I was? I'm here now. Why do I like that way better than this? Because what? Okay, so what can I do with it?
I don't know what the word is, but you can do like 5 square root of 5. Is that what?
Oh, okay, so how did you get 5 square root of 5?
Because you can't break up 5, but you can break up 25.
Okay, we know the square root of 25, it is 5. But we don't know the square root of 5. I don't know something that times itself will give me the square root of 5. It just leaves me with 5 times the square root of 5.
What's that called?
When you, simplest radical form?
Oh, that.
Yeah, so we break down a radical. Are we okay with that? Please feel free to stop me because it doesn't get easier with these after that. If something you don't like about, just call me out and I'll be like, sure, glad to explain to you. Okay, moving on to B. Who's up? Somebody help me out. Colette.
You would do 5 squared plus parentheses y minus 1 squared is equal to y squared.
Let me stop us right here. As she did everything perfect here. After this step, I feel like most people get this step. After this step is the kind of thing that if I were to put it on Friday's quiz, is where everything starts to go wrong right after this step. And not because of anything other than people are like, ugh, I don't remember what to do with this. I don't know. I'll tell you what the biggest area is. People make a huge mistake in this area right here. And we'll talk about that in just a minute. A huge mistake in that area. But let's go forward. Maybe it won't happen. Maybe because I pointed it out, we'll avoid that disaster.
So you would find what you can, just 5 squared, so that's 25, and then it would be plus y squared minus what is that?
So let's talk about that. So let me go back a second. This is the area I'm most worried about, that highlighted yellow area. I'm going to do this off to the side here because this is the number one area where mistakes happen. So I'm going to do this, just that little part off to the side. Now, would you agree that y minus 1 squared is the same thing as y minus 1 times y minus 1? Are you okay with that they're the exact same thing? Okay, so all I'm going to do is switch it out and go, okay, well, I think it's easier to do the math this way. So how do I actually go about multiplying this out right there? We're going to FOIL it. So let's FOIL it. right? I mean, it looked easy enough, but it turns out that there was more to it. So let's FOIL it out. What's the first term times the first term? What does that become? Y squared. And then the outer term times the outer term. What does that become? Y times negative 1. Negative y. And then the inner term times the inner term. Another negative y. And then finally, we've got the last term times the last term, which becomes negative or positive? A positive 1. This becomes y squared minus 2y plus 1. You see how that's a lot different than what we were going to write down there? We have to be very careful with that. So I'm going to highlight this because that's where this is coming from right here. 25 plus y squared minus 2y plus 1 is equal to y squared. Right? That became much bigger very quickly. All right, Colette, keep going from there.
I have to simplify.
Okay,
So you could add the whole numbers together.
good. Add the whole numbers together. I like what she's doing here.
And then it becomes 26 plus y squared minus 2y is equal to y squared. And then you would have what's the other thing? Because I was gonna say that you could subtract y squared.
Okay, let's do that.
And then that becomes a 0.
That sounds great to me. That sounds fantastic. Baby Yoda, baby Yoda. 2y plus 26 is equal to 0. I like that much better, right? That seems way easier to solve now.
And then you subtract 26 from both sides. And then you divide it by -2, and that goes y is equal to 13.
That's perfect. So just to verify, I'm going to go in and let's say I needed to find all the sides. This would become 13 minus 1, which would be 12. And now look at those numbers. 5, 12. This is one of those Pythagorean triples that we identified. Now I needed 2 of them. Just because I had a side that was 5, I couldn't be like, okay, I know exactly what this is. I need to actually identify 2 of the sides there. Are we okay with what happened there? Any part of that you didn't like? Yes, yes, sir.
Can you go back, can you just repeat the order you did the FOIL?
Okay, so when you FOIL, the whole point of foiling is first, outer, inner, last. And I look at like this. So the first terms are, here's the first term in that group, here's the first term in that group. That's where we got the y squared. Then I did the outer, so this one's on the outside and this one's on the outside. I multiplied those two together and got this one. Inner, I got this one's on the inside. When I say inside, it's like, imagine those two things together. Who's on the inside of that group? That's -1 and y. And then finally, last, which is the last number times the last number, which became -1 times -1, which is +1. Cool? Yep. Last but not least, somebody hook me up. This one is not as scary as it looks. Yes, ma'am?
So we do x squared plus 3 squared
You're good. Sorry, I had to switch colors. X squared plus 3 squared.
equals 3 square root of 2 squared.
Okay, so 3 square root of 2 squared. Now this is so here's the area that I think if anything's going to give us trouble, it's going to be right there, right? It might be like, well, how do I do that? Keep going. Sorry.
And then we keep x squared. And then 3 times 3 is 9. And then you FOIL.
So this one is not foiling, but it's probably good to do the same thing that we are going to do. When we have this, it's the same thing as 3 square root of 2 times 3 square root of 2. The question is, how do I multiply those things? What is the rules for those? Like, how do I go about multiplying this with this? And the way I like to look at it is that if you notice these two, like let's look at just these right there, right? There's 3 times the square root of 2. The 3 is on the outside, right? It's like it's not inside a radical there, like whereas the 2 is inside. So one of them I call an outside number, and one of them I call an inside number. 3 is not contained with anything. It doesn't have a radical over it. So I call that an outside number. And the square root of 2, that's an inside number because it's inside something. Now here's how you multiply them. You have to do the outside number times the outside number and the inside number times the inside number. So what's the outside number times the outside number? 9. And what's the inside number times the inside number? The square root of 4. Now, am I done?
No.
Why not?
Because 4 can be like
It can be simplified to what? To 2. It was 9 times the square root of 4, but the square root of 4 is exactly the same as 2. And 9 times 2 is 18. So all of that mess back there ended up being 18. Keep going. Okay, subtract 9, and we get x squared is equal to 9.
and then the square root of wouldn't it be x equals 3 because
Yeah, perfect. Yes, ma'am.
Why did the square root 18? Like, why did we have to?
We did square it here. So it was squared right there. 3 square root of 2, we squared it right here. Like we did that squaring, and once we did the squaring, we ended up at 18. So that's why 18 wasn't squared. It had already been squared. We don't square it again. All right, any questions on any of those before we move forward? This is what you can kind of expect on your homework, and these are the kind of things that you should expect come quiz time. You go, I have no problem giving you things that work out where you have to FOIL when it comes to working out a triangle. I have no problem giving you things where you have a radical on as one of the sides of the triangle. You should be able to do that. But here's the thing that you need to remember. If you had difficulty with this, just remember is that it's outside times outside and inside times inside. In case you're like, I don't know how to multiply those together. All right. Find the length of a diagonal of a rectangle with a length of 8 and a width of 4. So they want the diagonal, meaning it goes from one corner to another corner. Let's talk strategy. Even if you're not sure where this is going, talk to me about how you would start this. Amber.
So I'm thinking the diagonal is going to be the hypotenuse.
Okay.
So, I mean, I would draw this out just so I could get
That's exactly what I would do, is draw myself a picture to see exactly what we're working with to help me understand what's going on here. Now help me label. There's a rectangle, right? I drew a rectangle.
Okay. So I guess, the tall side, maybe you're going to do...
When you say tall, do you mean up and down or the longest side? Because sometimes people mean up and down, but sometimes they mean the longest side.
No, up and down.
Okay. What is that?
Might be 4 just because it's smaller.
Yeah, that's the width. And the word length just means the longest side. When you see like even if it's going even if the rectangle is laid at a weird angle or something like that, the longest side.
And then the longest is going to be 8.
Keep going. You're doing great. And actually, you said something earlier that would be great to apply here. Not sure?
Maybe they're right angles.
Okay, it's a rectangle. All of these are right angles, that's for sure. That is definitely a piece of information that we would not have been able to go forward without. What else do we have?
Well, the diagonal would be the triangle split in half, right? Like in a diagonal.
Okay, would you prefer me draw one of the diagonals from the upper left to the lower right? Or I just want to do it the way that you're thinking it. So, or lower left to upper right.
lower left upper right.
Okay, so she's looking at this here. Okay, so we want the length of the diagonal.
So now you're going to do 4 squared.
Good. Now let me just pull this out. If you can't see what she's seeing, this is what she's seeing. She sees this in there. That is this whole area right down here. Okay, I'm sorry. Keep going. 4, you said 4 squared?
4 squared plus 8 squared equals c squared, I guess that's what. So now 4 squared is 16. 8 squared is 64. Equals c squared. And now you're going to add that, which is 80.
80. Is it 80 or 80?
It's 80.
Just 80. Okay.
And now you're going to find the square root of 80. Which,
I'll zoom back out. I realize people are still writing.
I'm not really sure about.
Okay, that's okay. Listen, you've taken us this far. This is awesome. Anybody want to help her out in breaking down that radical? Because this, if you got this far, would not get you full points on a quiz.
80 can be broken down into the square root of 10 and the square root of 3.
Okay, that is definitely true that it'll break down to this. Now, I'm going to make the recommendation that there's nothing wrong with the way she's doing it, but she's not going the fastest way. Here's what I do is when I break these down, I am looking to see if either one of those can be broken down into 2 factors where one of them is a square number, because it makes my life so much easier if I can immediately break one down. Yes, ma'am.
The square root of 4 and the square root of 20.
Good. 4 and 20, I can definitely break one of those down. Now, I actually know that there was a different one, a bigger square root, but that's great. That actually is something right there that we can work with. So there was a bigger square number we could have used, and I'll show you what that is in a minute. But right now, this is good enough to get us started. Okay, so where can I go from there? Keep going.
The square root of 4 is 2, and then 20 breaks down into 4. The square root of 4 and the square root of 5.
Good. So notice she said that the square root of 20 is not done. It breaks down into the square root of 4 times the square root of 5. It still breaks down. And the reason that we're having to break down twice is because what that means is we didn't find the biggest square number. It's still going to work. It just means more steps. Keep going.
And then the square root of 4 is also 2, and then you times it times the square root of 5. Because you don't know what square root of 5 is.
Okay.
And then 2 times 2 is 4, so you get 4 square root of 5.
Okay. So here's the thing. Well, what if you're like, well, what was that larger number that was in there? And let's say you're like, I just can't think of it. What would the larger number be? Think about it. If this 4 had still been inside there, some number we took the square root of some number and ended up at 4. What was that number? We took the square root of some number and it's 16. So the truth is that what we could have done from the beginning is, if we wanted to, is we could have broken it up like this. And that would have done it in one step, because I would have just gone 4 square root of 5 right there at the beginning. But it's not wrong to do it the other way. It just takes more steps. That's why I always say find the biggest square number you can. It'll save you work. But if you don't find the square root of, if you don't find the largest square number, that's okay too. You're just going to have a little more work on your hands. It still ends up as the same thing. Okay, now it's working. So the diagrams of a rhombus, just in case you are unfamiliar with what a rhombus is. So a rhombus is kind of like what most people would call a square, diamond, but it's not just any diamond. A diamond. A rhombus is not like square sides are a rhombus congruent. Is going to have the properties of, but it doesn't have to have right angles. So I'm just going to do it like, let me just draw it like, I don't know, I'm going to draw it like, how about this? So a rhombus has 4 congruent sides. That is true. Now, they want to know about the diagonals. Now, here's some things I'm going to make on the side here that are true about a rhombus. So just because this is going to come up a lot, a rhombus, here are some things that are true. Just make yourself a note, because if this comes up again, something with the rhombus, you need to know that. That is true. Also, what is true is that our diagonals are perpendicular. Meaning, I'm going to zoom in here, that when these two diagonals meet up with each other, they form right angles. There, 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 there. Okay. Now, the lengths of these are 16 and 30. The diagonals of a rhombus have lengths of 16 and 30. Find the perimeter. Okay, so we know 16 and 30. What should we do to figure this out?
Is this like a bisector? Because I feel like based off of the rules we learned.
What do you mean a bisector?
Like, let's say if one length of them were, like if it was 16, then each side would be 8.
So you're saying if this is 16?
Yeah. There would be 8 and 8, just because it's a perpendicular and then
Yes. Yes. So they do. She's asking about this. So, like in this right here, she's saying, is this, can I split this up into, let's say that was the 16 one, then 8 and 8. You can, I think that will kind of lead you in the wrong direction, though. No, actually, I'm okay with that. Actually, I think that'll lead us in the right direction. I'm okay with that. Okay, so we've got 8 and 8. That's a start. Okay, so that's something. Colette, you got something else?
And then it'd be 15 and 13.
Okay, so here's what we're doing. Since one of the diagonals was 16, I just decided to pick one and call it. So notice that the 16, that red line there, I said, okay, well, let's just pretend it's that one, and then it's 8 and 8. And then Colette said, okay, well, what about the 30? Let's call this one 30, and then make this 15 and 15. Now notice we have 4 right triangles in there. If you can't see them, there is one right triangle here, one right triangle here, here, and there. But we're looking for the perimeter of this shape. Yes, ma'am?
What we do is, because they're all moving it, you only go into find one side.
Good. She's saying if we find one of these, we know all of them. Okay. So she wants to work on this upper left-hand right triangle up here. I'm just redrawing it. I'm imagining extracting it out of there just so I can look at it like this.
And then you do, so you're missing the hypotenuse.
Okay?
And so that'd be C. And then you have 8, which would, well, substitute for A, so it'd be 8 squared. That's 15 squared. Is equal to 2 squared. And then you would solve, and it becomes 63 plus 64 plus 225 is equal to 6 squared. And then we add the 2 together. And you get 289
289.
is equal to C squared.
Mm-hmm.
And then we solve that.
What do you mean solve for that? What do I do?
Oh, sorry. And then you find the square root of 289 squared.
What is it? Sorry?
And then it'd be C is equal to 17.
Did you just calculator that? You just calculated that, didn't you?
No, I'm not a human calculator.
So human calculator, you'll really like this. So here's where everybody gets happy. Chapter 7 is called Right Triangles and Trigonometry. When we get to the trigonometry portion, you can't do a lot of it without a calculator. So everyone's been asking, when do we get to use calculators? It'll be during Chapter 7. There's going to be some things that we're going to do, and they tend to be like, a lot of people will tell me it was their favorite part of geometry is like, oh, that part where we did trig, that was my favorite. It actually happened to have been my favorite part as well, but just something that's coming up. So we'll talk about calculators when we get to that portion. If you have a calculator, start bringing it with you so that when we use them, you're going to have it. You can have a scientific calculator. You could bring a graphing calculator. Graphing calculator is probably more than you need. It's not going to give you any extra advantage. But one of the two will help you out. All right. So in this case, one of the sides would be 17. So is that my final answer, 17?
And then, no, that's not your final answer. So then,
Because we want the perimeter.
so you know that all the sides are 17, so then you just multiply 17 times 4, because there's 4 sides. And then you get 60.
What does it equal?
68.
68.
Why did you tell me to
Why did we multiply it times 4?
Because there's 4 sides.
Because each of these sides we decided was 17, and it asked us for the perimeter. What we did was figure out, like this little triangle that we figured out right here was actually this one right there. So we only figured out that little portion there, that little portion was 17. And there's 4 of those little portions. All right, one more. Now, whoever decides to do it is going to tell me something, and they're going to say, this is this. They're going to make it an assumption. I shouldn't say an assumption. And I'm going to ask them to back up why. So be prepared that on this one, somebody's going to tell me something, and I'm going to say why.
The top, it's bisected.
You're saying that this top side here is bisected?
Yes.
Why?
Because of the perpendicular bisected.
Woo! So, because this is perpendicular and it is equidistant from the endpoints here, it means that it must be on the perpendicular bisector. Therefore, I am totally okay with calling this part 3 right there and this part 3 right there. Nice work. Talk to me. Keep going.
Alright, so it's going to be a set formula, so it's going to be 3 squared plus 6 squared equals x squared. Then we find the square, so it'll be 9 plus 36 equals x squared. And then we add them, which is 45. And then x, that equals the square root of 45. And then we do 9 and 5.
Okay. I like those because I can definitely take the square root of one of those, so that's much better than where we were.
X equals 3 times the radical 5. Yeah, 3.
Beautiful. And that's all we've got, folks.